Hi, welcome to 6-4. This is slope-intercept equations for lines. In the last lesson I mentioned that we were going to find an easier way to find the slope of a line given an equation, and this is what's going to do it for us. The line that contains the point 0b, where 0 is 0 and b is just some number. What that means is the x-coordinate is 0, the y-coordinate is some number. This is another way of saying the y-intercept, hence the intercept in the slope-intercept equation identity. If it has a slope m, and again we're using m for slope, I don't know if you've tried looking up what that means, but I think a good way to explain why we use m for slope is because slope starts with the letter m, and that's as good a reason as you're going to get. Anyway, that was a joke. Really. So it has a slope m, and it has the equation where y equals mx plus b. So y equals the slope times the x value plus b. And we can see that when x is 0, then y is going to equal b. So that is the point, 0b is that particular point. So this is the slope-intercept form. It's pretty useful because if we can write it that way, we know two things just by looking at the equation. Thing number one, we know that the slope equals some value. Thing number two, we know the y-intercept. We know where the line crosses the y-axis. That's what we get out of it. So I want you to fool around with some stuff for a minute. Let me change screens here. Got a site I need you to go to on your computer. The link is shown right there, and it's a slope slider simulator. And this goes along with the activity that's in the text that begins on page 348. And you should go through it just to get yourself comfortable with this whole idea of slope and what that means for an equation. Let me introduce you to the simulator. What we should do right now is you should pause me, get yourself online, get to it, and then come on back and I'll do a brief tutorial with you. Hey, welcome back. See you've got it there. That's great. I've got mine here too. It's this interactive slope slider. The purple box changes the coefficient of x, which is our slope value, our m. The green box changes our intercept, which is our b value for our equation. You'll notice that it has it in standard notation as a box here. I'm just going to click it just to show you because you're probably going to do it anyway. And so I can click on that and it shows me what this looks like in standard notation or something in standard notation. And then it gives it to me in slope-intercept form. That's what we want right now is slope-intercept form. It has it set to use decimals. You could use decimals or fractions. That's up to you. I like having grid lines, so I would mark the grid lines. I think the lighter ones work better for me. So what you want to do is take a look at the activity. You've got this set up so that you can look at the values of for y equals mx, the b value is set to 0. And the first thing it tells you to do is move the slider so that m equals 2. So I grab it and click, and I slide it over, and I've got m equals 2. We now have a new equation, and slowly we can move the slider, and we can move it to the right. What happens? That's the question you're being asked. Then you're going to move it to the left. So now that you've been introduced to this, go ahead and go through the activity, answer the questions in activity. If you want to fool around with things in here, of course, go for it. Pause the video. When you're done, come on back, and I'm going to continue with some examples for you. Okay, here we are, example 1. Write the equation. Negative 2x minus 4y equal 12 in slope-intercept form. Give the slope and y-intercept of the graph. You need to rewrite this in slope-intercept form. In standard form, the coefficient of x is not the slope. So don't be confused by that. It has to be in the form where y equals, where the coefficient of y is 1. And so y equals slope times x plus the y-intercept. So we're going to do a little algebra manipulation to get to that. So we get a negative 2x minus 4y equals 12. Since I want to get the y by itself, I'm going to add 2x to both sides. So 2x plus a negative 2x plus a negative 4y equals 12. What I do to one side, I have to do to the other, plus 2x. So 2x plus its opposite cancels. I'm left with a negative 4y. And that gives me 12 plus 2x. Now, in slope-intercept form, we tend to put the x variable before the intercept. Since this is commutative, it's addition, we can just move it. So that's 2x plus 12. Now I have to multiply both sides by a negative 1/4 times a negative 4. That's the reciprocal of negative 4. And I have to do this to all the elements, all of the terms on the other side. I could have used the distributive property, but I wanted to make it clear that I have to multiply 2x by a negative 1/4 and 12 by a negative 1/4. So this is going to, negative times a negative is a positive, 4 over 4 is 1. I'm got the coefficient of y is equal to 1. So y equals, 2 goes into 4 2 times, it's a negative 1/2 x, plus 4 goes into 12, how many times? 3, that's a negative, so plus a negative 3. And now we have it in slope-intercept form, where y equals the slope of the line times x plus the y-intercept. We now want to know what's the slope and y-intercept of the graph. Well, that's pretty easy. We know that the slope, m, equals a negative 1/2, and we know that the y-intercept equals a negative 3. We are done. We have taken the equation and written it in slope-intercept form, found the slope, found the intercept, and we're ready to move on to the next question. In this next one, we have in this example where we're looking at a graph, and can we find the equation of the line that's graphed below? Well, we know a couple of things. In slope-intercept form, the equation is y equals mx plus b. Previously, we found the slope of the line given 2 points, so we can find that. We have 2 points we can see. What's really cool is one of these points is on the y-axis. That's where the line intercepts the y-axis. And so at this point, the y value is 12, and the x value is 0, because it's on the y-axis. So the y-intercept which is b, is equal to 12. It's at the point 0, 12. The slope of the line, it's going to be negative, and it goes from 12 to 8, so this goes down 4, so m equals a negative 4, and then it goes over 4, 8. It goes over 8. And that can be reduced, so negative 4/8 is a negative 1/2. So we have now the slope and the intercept, and we can write an equation for the line. Y equals the slope, negative 1/2, times x, plus the y-intercept, 12. We have an equation for the line graphed. Y equals a negative 1/2 x plus 12. Okay, on to our next example. And in this example, We have a mountain climber, and this is, well, a mountain climber begins the second day of a climb at an elevation of 2,100 feet and climbs at a rate of 170 feet per hour. Find a slope-intercept equation for her height, h, after t hours. What's important in this is what's known as a direct variation problem. The rate, the slope, is 170 feet per hour, and it's constant. So that means it's going to form a straight line. So the rate and the slope are going to be the same things here. So I want to write a slope-intercept equation for this problem. Begins the second day of a climb at an elevation of 2,100 feet and climbs at a rate of 170 feet per hour. So what we'll need to know here is m, and we've got that. It tells us it's m is equal to 170 feet per hour. The units help us with that. And our b value, our intercept, is the start of the climb. So the beginning of time for this problem is the beginning of the second day. And where was the climber at that point? Well, she was at 2,100 feet. So 2,100 feet is our b value, because that's when x was 0, the beginning of time. X-axis is 0. X-axis is time in hours, t. The y-axis is height, h. So here's our information, and we can write that the height, h, is equal to 170 feet per hour times x. X is time, right? So x hours plus 2,100 feet. Now you'll notice that hours over hours will cancel out. When we multiply the rate times time, we get distance. And distance plus distance can be added together, and we can use that to find out the answer to part B. How high is the climber after 8 hours? So h equals 170 feet per hour times 8 hours plus 2,100 feet. Simple multiplication now, we get 170 times 8, and that gives us that h equals 1,360 feet plus 2,100 feet. And we'll add those two together, and we get that h equals 3,460 feet. So we've used a direct variation calculation to determine the height in the future. There are other types of direct variation problems. You're used to them. One is the distance type problem, where you're driving at a constant rate and you drive for a certain amount of time. How far did you go? That's a direct variation problem. That means that your value here varies directly as the time value varies. So it's a multiplier is the slope times whatever's going on, and it's constant. It's happening all the time. That's it for this slope-intercept section of the slope lessons. On to the mastery quiz. Best of luck with that. If you have any questions for me, if you want to get some double-check things on the activity, come see me in class. I will be glad to help you out. Take care.